Good afternoon to all the attendees, and apologies for the voiceover. In the meanwhile, the Italian voiceover. Thank you very much. And today we'll be presenting the identity-centric behavioral analytics approach by Sherlock for insider threat and fraud detection, as well as our capability of making or contributing with some action to the identity governance part. Today on stage, it's myself, Andrea Rossi, and Christian Lucci, the CEO of Sherlock, and I think we can get started. Just as a matter of fact, can you properly see my screen in presentation mode? And Christian, maybe you
can... Yes, Andrea. Yes.
Good. Perfect. Thank you very much. All right, so we're going to talk about a bit of a trends, platform, and a bit of competitive ROI, all the benefits we can bring to this market. Questions at the very end. So first of all, we are in a journey of change. Insider threat and fraud detection is heavily reshaped by machine learning, and it's reshaping the old approach of finding or detecting threats. If you look at the market today, a lot of the security vendors, including those focusing on insider threats, are based on rules, or as we call them, indicators of compromise. Where the market is moving is really detecting threats based on behavioral anomaly detection, and that requires a good amount of machine learning. I would say even new age machine learning, not the old style stuff. Where we head into, and that's something that you will see in the product in the coming 6 to 8 months, it's the ability to move from identity-centric behavioral anomaly detection to graph-centric. What I mean by identity-centric, I think it's rather clear, but it's not a given. You need to be able to bind anomalies which are coming from non-identity-centric sources, binding them to a human identity, or in general, it's an identity. It could be the identity of a machine, okay? So the concept of identity is slightly broader. And where we're moving, it's the graph-centric, which is basically addressing the ability to detect partners in crime, because there are changes that happen on a team of people rather than on the individual. Just a very quick example to explain for setting the basics. What's the difference really between old system using rules and new system using behavior? In the old days of rules, if you wanted to detect a very basic anomaly, the too many logins, the rules had to be carved out in stone, and you had to script the amount of failed logins. Reality being that 2 doesn't mean anything to the average user. It's too few for me, way too many for Christian. So you need to bind it to the individual habits or bad habits. And so the new interpretation in the behavioral world is raise an alert every time the user has a significant deviation over his or her behavioral baseline. In that specific case, on the failed login behavioral baseline. Quick company overview. It's we've been established in 2017, and the team comes from Cross Ideas, or at least 80% of the team comes from the Cross Ideas, a former IGA vendor which has been acquired by IBM in 2014. The company took its time to really innovate and disrupt this market of behavioral analytics. And I think one important validation is the ability of the company to obtain a patent, which was received or granted in June this year. So our mission is really to provide true, and I sort of amplify that, true identity-centric behavioral threat detection and compliance. And we'll try to be specific, showing you the product demo as well, so our interpretation of it. So let's take a brief look at how we operate in action. So in action, there are a bunch of typically applications or systems or um, yeah, data silos that are used by users, and that varies from sophisticated business application to firewall and VPN, but even access control systems like accessing a physical warehouse. Um, all this stuff is collected. The access behavior, the access log file are sent over to Sherlock, and we basically do three things as a tip of the iceberg. We collect the data, we find the baselines for each user of that community. That's very important. And then we detect the anomaly. Now, when it comes to anomaly, we say we want to detect a behavioral anomaly, and that typically goes on humans. So identity-centric means a human identity, but also non-human. There is nothing preventing a machine with sensors to operate in the same way. And we have a lot of exchange of data with identity management platform being a consolidated directory or being an IGA platform. And in a nutshell, we do two things in exchange. We take and we give back. We take the ability to enrich the identity with all the surrounding attributes that might be present in identity management or in general IGA platforms like SailPoint, IBM, Saviynt, One Identity, and so on. And we provide back alerts and recommendations. We're going to be specific on the type of alert and the type of recommendation. And that goes into the next chart, which is, if we look at what we do, we sort of detect two types of anomalies. The one on the left, it's pure threat and fraud detection, and has to deal with the starting an action for remediation or preventing that type of fraudulent activity. On the right, you have what we call access compliance. So let's, while I think that the threat and fraud detection on the left is rather clear, for access compliance, it's the ability to measure the gap between the provisioning policies, so to say, that are set in an IGA system, comparing them to the actual behaviors and measure a gap, and that gap is a compliance gap. And we provide recommendation to close that one. Now, when we started back in 2017 to really start out to innovate in this market of, that was called then user behavior analytics, we understood that we had to innovate in the foundational thinking of it. And we took inspiration from Agatha Christie. And the famous statement that one coincidence is a coincidence, three coincidences are a proof. In the world of behavioral analytics, it's sort of the same. And in a nutshell, you need a bunch of clues, way more than the usual old players in this space are able to provide. So we designed a sort of a building block, which is our interpretation of the indicator of behavior. So the indicator of behavior is a metric for each baseline we want to build, and we can have thousands of IOBs, as we call them. Why that? Because it's a triplet on a given machine learning model that we can offer out of the box, and you will see that during the demo. The data set, which simplistically defined, it's a log file from SAP, Office 365, or the VPN, and the log field. The log field is the specific field in the data set that you want to create a baseline on. Very simple example is email exchange, email log file. You have a number of attributes for each mail that someone is sending to other recipients. So the attribute could be someone else's email, the size of the attachment, the number of emails. So just for the email system itself, we can build many indicators of behaviors, and because it's just a combination of it in the threat modeler that gives the ability to address one of the original sins of this market, which is historically they were generating too many false positives. So we were talking about machine learning. We could stay 2 hours here and detail on what we do. Just on a very high level standpoint, our machine learning developments have concentrated their efforts in two pillars. The pillar on the left, it's for an algorithm models for detecting the anomaly itself. Um, we'll see them during the demo because we are building IOBs during the demo, which is taking place very soon. But they have one thing in common: they are unsupervised. That means that you don't have to prepare the data set for training the system, which is typically a showstopper for many tools of this type. If you are required to prepare a training data set, or in other words, if you are using a supervised methodology. On the right, we have a different set of machine learning, which aims to find the identity even when it's not available, or at least try heuristically to narrow down to maybe one or two potential identities that are behind that log line. And we do that meshing, so to say, IP and MAC addresses attributes that in a way are able to say, well, that log line could either be generated by Andrea or Christian. So that's the behind the scene, and it's summarized in one slide, but I have to tell you, if we got the patent, it's because of this approach and the architecture that we've put around it. Now, let's pause for a while, then we'll come back to a second few more charts, and I hand over to Christian for the first demo on what we call the threat and fraud detection set of capabilities. Now, Christian, let me stop the sharing, and I think you should be good to go with your screen sharing. Very good.
Okay.
And we'll get back to the slides.
You see my screen?
Yes.
It's perfect. So let's go. This is our dashboard, the entry point where we can find a summary of the current situation of the system. We can see here the number of alerts triggered and the real-time data that are flowing to the system. Being a static demo, there is no data flow right now. In the central part, we can see the big numbers relating to accounts, users, and assets. The system warns us about the number of inactive accounts found, the number of ghost accounts that are those that have been seen in the logs but they don't have a match in the identity governance. And the system warns us also on the number of orphan accounts, that are those accounts which no match between users. We find then inactive users, risky users, and inactive assets. Assets means database, workstation, or some kind of sensors. In the next section, we can see peer groups calculated dynamically based on real user behavior. So not a static clustering based on a single attribute such as, I don't know, organization unit, location, or user manager, but clustering based on users' real behavior. Clicking on this group, for example, we can see its population and we can see user were part of it. I would like to explain the difference between risky users and anomalous users, or more generally between risk and anomaly. The anomaly is a single signal that warns us that a given behavior is different than its baseline. And this is not necessarily a bad thing. It can be due to a normal or control, even like corporate structuring, deployment of a new application, introduction of a new business process, and so on. The risk is instead calculated after the modeling of a threat, and it's a correlated set of anomalies that's indicating a real dangerous scenario due to an attack pattern of some kind. So we can see here the top anomalous users ordered by global anomaly score. Among these, there may be users who are protagonists of some threat and users who are simply anomalous. This to say that even if no threat is modeled, without any type of configuration, the system automatically uses indicators to detect behavioral anomalies. Finally, in the lower part, we can see the summary of the alerts that the system has generated. In this case, we can see that a data exfiltration attempt is in progress. So let's go to the functionality of account behavior. In this section, we can view the details of the accounts analyzed by the algorithms. In particular, we analyze a SharePoint account. But go on to the last section, which is maybe the most important, the timeline. Here we can analyze the behavioral indicators that are running in the system, sorted in chronological order. As we can see, this account on February the 5th received an anomaly score of 100%. Going deep into the indicator, we can see that this account has access to SharePoint HR Orga folder, and it usually accesses it with an average of 2 times a day, but on this particular day, it has access to 246 times. We can find another clue of its anomaly going to its peer groups. We find here the peers behavior of the account, and as we can see, this account doesn't cluster with anyone, and so its behavior is anomalous, even looking only at this chart. Here there should be a cloud of other accounts that behave similarly to it, but for some reason this doesn't happen. Now we know that a particular account of a particular application at a specific moment of a specific day was anomalous because it accessed a much greater number of times than its normal behavior to a particular folder without any type of static rule or policy. We know everything. We just have to download here the small portion of the log that refers to this day to complete the analysis and have all the elements to make any decisions. Downloading the log, we can see the raw messages, which contains all the information necessary for the analyst. This account is linked to a user, Giuseppe Martinelli. Now let's go to user behavior to level up and move from account analysis to user analysis. So clicking to Giuseppe Martinelli, here we go. As for the account behavior, we see the upper part the user data, and then in the central part of the view, we can see 4 tabs that show us in detail the daily behavior of the user and other important details about the context in which is moving. Here, in the first tab, we have a view of all its accounts and their use over the day with a graphical representation of the intensity of use of the single account. In the second tab, we have the details of the accounts and the MAC addresses of the devices used by the user. Now we are analyzing the behavior of a user, a real user, and we do it through heuristics that allow us to map from the IP address found in the network logs to the accounts found in the application log that the user uses for his daily work. User information comes from identity governance, and we use this info to enrich our security events and data very precious context. Going forward with the third tab, we find the time intervals in which the user was seen by our system. Now, not only one account, but in an aggregate form relating to all his accounts. We can see the user working days week by week divided by hours that we can inspect simply clicking on it and reading more details. In the last tab, we can see the behavioral group of the user, and here we can see what is peers, as we have already seen for the account behavior. A very simple and quick way to see if there are anomalies about this behavior and these peers. Let me say, in a perfect world, a developer should be in a group with other developers and should not be in a group with sales, for example. Finally, we find the timeline but this time related to all the accounts associated with the user and not only related to SharePoint application. In particular, we can note that its percentage of anomalies regarding the sending of emails outside the company with attachment is 100%. Regarding the use of SharePoint is 100%, as we have already seen in the account behavior section. And regarding the use of VPN is 49%. Going into the details of each indicator, we can see why the user is anomalous, and downloading the small portion, the related log, we can do all the analysis we need. So Giuseppe Martinelli has accessed SharePoint in an anomaly way. He used his email in an anomaly way too, and he used a VPN in a wrong way. There is a data exfiltration attempt. We talked about anomalies, we talked about risk related to others. And so now let's go quickly to see how a threat model is built. The indicators are the basic elements of our system, and they express the idea of what you want to analyze, the data set, the log, and how you want to analyze it, the algorithm. And they can be put together to model something more complex like a threat. Let's see, for example, the threat related to this data exfiltration scenario prepared for this demo. In the left part of the view, we can find the list of available indicators with a shortcut here to create a new one in case there is not what we need. The threat is a model of the kill chain of an attack, and the indicators can be added to the various stages of the kill chain to model attack steps. In a few words, we can think to the anomalies detected by the indicators as a set of clues that trigger an alarm, and putting them together, we can detect a fraud attempt. As I said previously, even if no threat is modeled without any type of configuration, the system automatically uses indicator to detect behavioral anomalies. So we don't need to model a threat. With the threat configuration, with this part, we finished the overview of the function most closely related to cybersecurity domain. So Andrea, the stage is yours. Or for the second part about the identity governance domain.
Yes, I'm back. So let me put back the few of the charts. All right, okay. Good. I think you hopefully can see my screen again.
Yes.
Okay, good. So let me tell you a bit about how this market evolved over time, because you might have heard this word of identity-centric behavior analytics or user behavior analytics many times. So the first generation had a very basic issue. It was the live statement or the live proof that these solutions were, in the word of the boy who cried wolf. Too many positives, and we're creating distrust over the threats that were detected. And that's exactly this type of phenomena that you need to deal when you have a lot of false positives and the end user using the platform are losing the trust. The other thing, they were requiring a bunch of machine learning skills, or in other words, you had to prepare a training data set for this platform. Just to give you an idea, Securonic, Juricool are two representative vendors of this first generation. And behind the scene, they had two old style ingredients. First of all, they were all supervised. So you had to prepare a training data set for the machine learning systems. But most importantly, that behavioral baseline was not at a user level. It was I call it group behavioral baseline. Just to make a very simple example, if you have the log file coming from Exchange, Microsoft Exchange or Office 365, they are creating a sort of an average user on the entire file. That average user does not exist. So each user has, by definition, a deviation from that average one. And that's the reason behind the presence of so many false positives. We are in the second generation. A second generation means software that has been built over the last 2-3 years. We started with the obsession of dramatically reducing false positives, and you can't ask people to have machine learning skills or equivalent. And that goes with the unsupervised capabilities and the ability, and that's very unique in our case, to build individual baselines. So is the company 3 users? We don't care. We build at least 3 baselines for 3 users. Reality can be 450 baselines for the 3 users, because you can build indicators of behaviors for different attributes within different log files. So that's one of the key things that are making us different nowadays. Of course, we're not the only one reinterpreting it, starting from the old style or first generation issues. Let me tell you a bit about a case study. One of our clients, it's a financial information providers, and it's quite big. I mean, it's over 6,000 employees scattered around the world. And these guys are growing like hell through acquisitions. And this large population of users for the business they're in is dealing with very, very, very sensitive information. But they require an agility which can't be fenced into the usual or the classic security system where you really define a bunch of policies and rules and you fence off people from one system to the others. And in fact, a bunch of the stuff they had, well, actually have, like a CM platform, the endpoint management, were way too rigid for managing the need of detecting anomalies based on behavior. In fact, they built something on their own. So they had an homegrown built behavioral machine learning custom code that, of course, was no longer adequate for the new needs. Even the DLP, data loss protection systems, were too rigid for their needs, because DLPs are typically set with policies. Okay, any file of that type can be moved to an USB key. It was way too rigid for their agility requirement. So they have deployed Sherlock for the entire user population. At the moment, we have put into control the collaboration, conferencing, actually also the entire source code development, DevOps type of work. They're building a bunch of software. And it's really focused on the data exfiltration, threat detection, and prevention, where data, can be the data itself of, consumer users, as well as software and algorithm that they're building as part of their daily routine. Of course, needless to say, they've been able to increase their ability to detect insider threats thanks to all the stuff we provide, and they are able to have a way reduced number of false positives compared to their homegrown system and compared to the attempts they made using some rule-based systems. And of course, the TCO has gone down because they just feed Sherlock with their log file, and there is no need to train anything in the system because, again, our platform algorithms are unsupervised. Now we get into the last part of the presentation today, and it deals with not a threat detection related, but a compliance anomaly detection, as I told you at the beginning. What you see here on the right, it's right from our data scientist bench, and it's that coffee spot is real. And that's the essence of what's behind the scene in what we call in-compliance score. So the in-compliance score, it's still using our same ingredients, but for measuring an individual gap between how a given user should be profiled and that's what we call the IGA peers. These type of data is coming from IGA platform versus the behavioral peers. And you can see this example, this guy, should be surrounded by nice sellers. The reality is surrounded by also other people in the actual behavior. So maybe there is something to investigate for closing the gap. Again, here we were not detecting a threat, we're detecting a gap, which is typically a source of non-conformity in case of audits when they investigate if you are properly defining and enforcing your identity provisioning policies. Now let's go back to the last part of the demo. This is going to be slightly quicker, and then we'll reconvene for the final conclusions.
Okay, here we go again. Do you see my screen, Andrea?
Jawohl, yes.
Perfect. So, we have seen our clustering algorithms in action a couple of times. The first time to discover the behavioral peers of accounts, and then to level up the analysis and go to find the behavioral peers of users. We will now use these algorithms for functionality closer to identity governance domain, looking for any anomalies between the word of provisioning and the word of behavior. In the upper part of the view, we can see two colored bars. These bars represent the user groups related to identity governance word and the user groups related to the real user's behavior. We can cluster users on any static attributes such as organization unit manager, location, and so on. All data coming from the identity governance system. In this case, we have clustered by applications, and so in each group, we find users similar for the applications to which they have access. Here in the first bar, we can see how many identity governance group we found and how large they are from the population point of view. The same thing about behavioral groups. Here we can see how many behavioral groups we have found and how large they are. Let's go into more detail, going to the central part to analyze the composition of each group. We can see here now many behavioral groups. An identity governance group is composed, let me say, in a preferred word, a group of user provisioned in the same way will behave in the same way. And so the correspondence between identity group and the behavioral group will be 1-to-1. Vice versa, if there is a large fragmentation, it means that something is wrong. Users are provisioned in the same way, but their behavior is split into many different groups, and the reason must be investigated. The same thing in the other tab, but with the inverted parts. We start from the behavioral group, and we see its fragmentation for identity groups making the same consideration. We are talking about groups now. Begin to talk about individual users, introducing a new concept, the incompliance score, which is the measure of the distance between user assignments and his actual behavior, calculated looking at his peers. So the greater his incompliance score, the more there is a difference between what he has access to and what he uses, because for example, his bad provision. To better understand, let's go to see Marian Gonzalez, who has a score of 70%. We have three columns here. In the left column, we see her identity governance cluster. So there are all users similar to Marian based on the applications they can use. In the central part, instead, we see her cluster relating to real user behavior. So it's true that she can use a certain number of applications, but which ones that she use? This column answers to this question. First consideration, we can see in the list below that Marian has access to 12 applications, but she uses only 7 of them. But the question is, if you behave differently from your identity peers, how do they behave instead? And then we come to the third column, list of Marian's identity governance peers based on their real behavior, and below the list of applications they are using. We come now to a deeper consideration. Marian has access to 12 applications. Actually, she uses 7 of them, but she should use 6 of them looking at her peers. Conclusion, Marian probably is heavily over-provisioned, has access to some application that is twice as many as he should have. So I'm done with this part of demo, but let me say one more thing. From here, with our algorithms and with our data, we can model a lot of use cases such as automatic recertification, recommendation, and so on. We are trying to close the loop between what we have, identity governance, and what we use in the real life application log. So that's all from this side. Okay, perfect. The stage is yours again, Andrea.
Yeah, and as usual, I should turn my microphone on. Good. So we're back in the final few minutes, and then we open up for Q&A. I already see 2 questions popping up there. So the value proposition, first of all, apologies for the blue dot. Number 1 and number 2, we call ourselves zero-day start because you need to forget about rules. Our system, as you might have seen, has no rules. Might have few thresholds here and there, but the system operates as a human being, trying to detect changes of behavior based on the habits. This is sparing you a lot of time when you have to prepare data. That's how we call a zero-day start. We also provide a massive reduction of false positives, and we want to be specific and measurable. We have tested it, and as you can imagine, there are ways of testing it against benchmark data sets. And our ability to, not on the single algorithm, but on the ability to combine many clues, many IOBs, is reducing the likelihood of false positives by over 21% compared to our competitors, meaning machine learning power solution, okay? So that's very important because in a nutshell, the USP number 2, it's the way to address the original sin of this market. The number 3 and 4, you get in the same platform the 2 capability on threat detection, threat and fraud, and compliance. And that's, again, it's a value because that's typically seen in separate platforms. And the other thing, it's connected to the age of the platform or the young age of the platform in a positive way. It's been built on fully microservices, Kubernetes. So our software runs same capability, actually same software over our cloud deployment on AWS as well as on-prem Kubernetes clusters. And the beauty of that is that you can, if you are not friendly on sending your log file to our AWS instance, then you can start on-prem and then over time migrate to our cloud instance and nothing changes because the software is exactly the same. So there is no need to repurpose anything. And as you know, many vendors that started their the development back in the beginning of this decade, they have two products. One which is cloud with a certain set of features, and the other one, it's the old on-prem one. Now, I wanted to close with a bit of identity management messaging because you might have seen a bunch of capabilities here and there. I would like to take this final slide for summarizing the way we can build, help, identity platforms like, One Identity, SailPoint, IBM, IGA platforms in general. So first of all, our tool can be used for assessing the past. So if you feed us 6 months of historical data, we can help you understand, on one side, strange behaviors, but at the same time, it's also a way of modeling roles based on common activities rather than other fancy theoretical attributes. On the implementation phase, we provide this great capability of helping you in matching orphan accounts. And if you are in this space, you know how painful that is. So the way we do is using our peer analysis models, where sort of an orphan account can be linked to a real identity based on the behaviors of known peers. In the optimization phase, we can help you in removing unutilized access. And then there's also this why don't you remove section, which you have just seen, okay? And with the goal of making the two, the should be versus the as is behavior as close as possible. And last but not least, we finish with what we started. So as we detect identity-centric threats, we funnel back that information to the identity platform because we speak the same alphabet. And then you can block the accounts, block the identity, suggest user reviews, and even detect ghost accounts. The ghost accounts are those who are basically not listed or enrolled or visible in the IGA platform, and we are able to observe them and inform back. So in a way, identity management becomes our SOAR system, or security orchestration and remediation, because here our threat is identity breach, and then your counter activity, your response measure is based on doing something on that given identity. Conclusions, and then I'll start addressing the first two questions, and then we'll see if we have more. So the conclusion is, guys, I think it's useless to say that identity is the new perimeter. We have been hearing that for ages, but the reality with COVID, I mean, this stuff became real because all the users and employees and contractors are working remotely, and God knows who's really behind those user credentials. Is that still you, or someone else has stolen their data and impersonating you and having a different access behavior? Accuracy is the name of the game, and we put a maniacal obsession into optimizing that. And we think that in general in the market, for the new players like us, we can really walk the talk of declaring that the days of the boy who cried wolf are over. And last but not least, the team, of course, Sherlock has 80 to 70% of its foundation in the team that built CrossIDEA. So we think to know what identity-centric mean. And we sort of see Sherlock as a sort of an evolution of our history. So from static policies to a new governance based on actual behaviors. And with that, that was it.